Good morning, everyone. My name is Alex Slatke, Director of Public and Government Affairs for AAA Northeast, and we are delighted to have you with us this morning for our webinar about adaptive cruise control. And we are especially delighted to hear from Sam Monfort, who's a statistician with the Insurance Institute for Highway Safety. And Sam was the lead author on a study that's very interesting about adaptive cruise control. Seeing how well it induces or doesn't induce drivers to speed even more than they might normally. So we're really looking forward to the discussion today. I will just make one quick announcement that if you have any questions that you'd like me to ask Sam that come up for you during his presentation, feel free to drop them in the chat and I'll try to get to as many as I can. But without further ado, Sam, take it away.
Great. Thank you, Alec, for the kind introduction, and thank you all for attending this talk. I'm happy to share the results of this study with you. Like Alex said, this study is going to be on adaptive cruise control and how people do or don't speed while using it. So let's get into it. All right, so when you're thinking about adaptive cruise control, you can kind of think about it in terms of vehicle automation. And we automate tasks for many reasons, one of which is to improve performance. But importantly here, automation doesn't remove our responsibility. When we take duties and responsibilities from a driver and give it to the automation, we essentially replace some responsibilities with different ones. What I mean by that is now the person driving the vehicle has to supervise the automation and make sure that it doesn't make mistakes. Importantly, the driver also has to activate the automation at the appropriate time and use it within its intended guidelines. So how might a driver use cruise control inappropriately? Well, as you all probably know, we're free to set cruise control to whatever speed we want, even if that speed is above the speed limit. An IHS study from the late 90s found that users might drive faster with adaptive cruise control. Essentially, they just recorded people driving and recorded whether or not they had cruise control on or off, and found that on average they drove a bit faster with adaptive cruise control on. However, this study didn't capture speed limit data, so it's entirely possible that what they found was, basically people just driving faster on the highways and also using cruise control on the highways. So in other words, a confounding effect. So we wanted to clarify this finding and update it with a little bit more recent data. And so I'll be presenting the results of a study that we conducted for this reason, really to focus in on the question of whether or not people speed more with adaptive cruise control, and to see how that speeding behavior might differ between the two types of vehicle controls. So why do we care? I mean, to be brief, traveling at greater speeds worsens many crash outcomes. It increases the distance needed to stop. It increases the risk for losing control during evasive maneuvers if you take them. And in general, it just increases the expected severity of a crash. Latest estimates from 2018 suggest that speeding is a contributing factor in 26% of all motor vehicle fatalities. So this is a pretty serious issue, and if we can understand why people might speed, then we can take steps towards mitigating that behavior. So it's important to note that adaptive cruise control might be marketed as a convenience feature. Drivers look at it and think, oh, this will make driving a lot easier. But we've also seen a lot of evidence to suggest that adaptive cruise control does actually improve safety outcomes. Research shows that it tends to maintain a greater lead time compared to human drivers, so more space between you and the vehicle in front of you. It's also associated with fewer lane changes, which are a type of maneuver that are linked with crashes. And our sister organization, Hildy, also found that vehicles equipped with adaptive cruise control also were, the drivers made fewer insurance claims when they were driving it. So there's some concrete evidence to show that whatever we uncover in the study that I'm showing you today, the net is a benefit, a safety benefit. However, if we know that ACC is beneficial to safety overall, people speeding with it is essentially just going to lower that ceiling. So whatever benefit we might be able to get if we drove perfectly with it, adaptive cruise control, we're reducing that slightly if we speed. It's also important to note that adaptive cruise control and also lane centering, which I'll get into a little bit in this study, they're pretty rare in today's fleet. So in terms of 2020 model year vehicles, only 17% of them have adaptive cruise control as standard. And so if you extrapolate the number of 2020 vehicles on the road, you can kind of see that in general, people aren't equipped with adaptive cruise control. However, the results of the study I'm showing you today can be used to understand what might be happening in the future as more vehicles get these systems, as they always do. Okay, I'm going to briefly describe the sample and how the data were collected, and then I'll get into the results. So to do this study, we partnered with MIT's Advanced Vehicle Technology Consortium, and they recruited 40 participants from Boston and gave them a vehicle to use in their regular commute. So come in, get the vehicle, use it however you want, basically. The only restrictions were they had to have a regular commute of more than 30 miles a day. So that was just a guarantee of a minimum level of driving that they would use the vehicles for. We had a roughly even split between male and female drivers, and the average age was 44. These drivers were either given a 2016 Land Rover Range Rover Evoque or a 2017 Volvo S90. Both of these vehicles had adaptive cruise control, but something important to note is that the Volvo also had a system called Pilot Assist, which is just adaptive cruise control with lane centering tacked on. So like adaptive cruise control maintains your headway, and lane centering just keeps you in the middle of the lane automatically. So in the end, drivers recorded about 20,000 miles driven, and we recorded these their position and speed at 1 time per second. We also limited the analysis after the fact to periods on limited access roads. Basically just think highways, freeways, and other roads with reduced access to the side and limited intersections and stuff like that. After the fact, we also linked the location with speed limit, so we could figure out what the speed limit of the road was that they were traveling, and then had to exclude roads with missing speed limits and so forth. So there were 2 main analyses that were the focus of the study, and I'm going to explain those first. First, we analyzed the probability of speeding. Essentially, this was were they speeding, yes or no? And then in the end, we'll get a % of the time that they were speeding. But we were also interested in the type of speeding. In other words, how fast over the speed limit were they going? Because you could imagine these being separate effects. The primary predictor of interest, what I'm going to be presenting on, is the control type. So were they driving manually, just with their feet and hands? Were they using adaptive cruise control? Or were they using pilot assist, which remember that was the Volvo's version of adaptive cruise control that had added lane centering. We also controlled for a number of things. This is just a statistical procedure that you can use to remove influence of things that you're not interested in examining just yet. For example, we controlled for speed limit, we controlled for the vehicle type, because remember drivers had one of 2 different vehicles, and we wanted to make sure that we took that into account. And we also controlled for trip number. So some research shows that people change their behavior over time using adaptive cruise control, just as they get more experience with it and whatnot. So we controlled for driver experience with the vehicles as well. We also conducted a number of secondary analyses. I'll present these at the end, but I'm just sort of priming the pump here to describe them. We wanted to know if there was an effect for speeding, if it varied by the speed limit of the road. We were also interested in the consistency of speeding behavior for any given driver. In other words, if you're the kind of person who always speeds while controlling manually, does that mean that you also always speed while using adaptive cruise control, and vice versa? And finally, although we didn't collect any data on crashes, we did use basically this formula that a Swedish researcher came up with to convert extra speed into crash risk. So it's just an estimate, but it gives us a general idea of, okay, if there are speed differences between manual control and adaptive cruise control, how do those speed differences translate into crash risk, which is really what we care about here. So first, I'd like to present just some exploratory results that I quite like this graph, and I hope you do too. You can see on the x-axis is speed over the speed limit, and on the y-axis is the percent of the time that the drivers were there. And so while they were driving manually, you can see the solid darkest line is just a continuous kind of hump. But then the adaptive cruise control groups look a lot more spiky, essentially clustered around, 1 under, 4 over, 9 over, 14 over. I'm sure some of you can relate to those speed choices. Essentially what we're seeing here is maybe people choosing a speed that they believe will balance their desire to go quickly and also their desire to avoid being pulled over. Also something to note, and I'll get into this later, the vehicles had toggles to increase their speed by 5 miles per hour. And that's also why we can see the clustered distribution of speeds for these adaptive cruise control groups. Okay, but remember, what we're interested in is the average. So we can see, for example, they're clustered at certain speeds, but on average, are they speeding more? And so what we found is that yes, on average, drivers, while they had adaptive cruise control active and also pilot assist active, tended to speed more than when they were controlling the vehicle manually. So under manual control, they sped 77% of the time. While using adaptive cruise control, they sped 95% of the time. And while using pilot assist, remember, adaptive cruise control plus lane centering, they sped 96% of the time, essentially equivalent to the just plain ACC group. Something to note though is pretty much drivers are speeding most of the time regardless, but this is a pretty substantial difference between manual control and adaptive cruise control. Okay, so next up, is speeding more severe with adaptive cruise control compared to manual driving? So in terms of raw miles per hour over the limit, we did find an effect, but I guess you could say it's comparatively small relative to the 20% increase in probability of speeding. What we're seeing is basically 1 or 2 miles per hour faster over the limit when you're driving with adaptive cruise control compared to manual driving. I mentioned that some of the secondary analyses we were interested in. One was the speed limit of the road. And so what we wanted to see was, okay, there's about a 1 or 2 mile per hour difference overall in terms of speeding over the limit, but does this depend on how fast the speed limit is? And what we found is that pretty much all of these differences happened on 55 mile per hour roads. So on 55 mile per hour roads, you see a 1.5 mile per hour difference between manual control and adaptive cruise control. But on 60 and 65, you just see, a couple of tenths of miles per hour over the limit. So this shows us that for the most part, these differences are happening on slower speed limit roads. So I mentioned before that we were interested in seeing how these differences might relate to crash risk. And now before I show you these results, I'd just like to briefly explain how the equation was developed. I'm not going to get into the numbers or anything, but basically the researcher Elvik compiled what we call a meta-analysis. So he took dozens of other studies that looked at speed and crash outcomes, and he created an equation that incorporated all that data to basically let other researchers like me plug in speed differences and see the percentage increase in these different types of crash outcomes. So basically standing on the shoulders of giants situation. And what we found is that a relatively modest increase of about 1.5 miles per hour while going at highway speeds was associated with a 10% increase in fatal crash injury risk, 4% increase in non-fatal injury risk, and a 3% increase in property damage only crash risk. And all of these were statistically significant. Finally, the consistency of speeding behavior within driver. So basically, if a driver speeds using adaptive cruise control, will they also speed manually? And what we found is that these two behaviors were highly correlated. So if you're the kind of driver to speed in one control type, you're also likely to speed in the other. And you're also likely to speed a similar amount over the limit. Okay, so to sum it up, we found drivers speed more often under adaptive cruise control than manually. They speed faster under adaptive cruise control than manually. And then all of this speeding seems to take place on slower roads. And lastly, that the amount of speed over the limit that they're traveling on these roads was linked with an estimated 10% fatal crash risk, 4% increase in injury crash risk, and a 3% increase in property damage only crash risk. So one of the things I'd like to draw attention to is the idea that small differences in highway speeds can have a substantial effect on crash risk. And the large differences that I just referenced are pretty consistent with past work. For example, one of our other researchers, my boss actually, did an analysis on speed limit increases, and he found that increasing the speed limit by 5 miles per hour was associated with 8.5% increase in fatality risk. So these small tweaks can have these seemingly outsized differences just because of the amount of energy we're talking about. You know, a 3,000 or 4,000 pound vehicle traveling at 50 miles per hour, increasing it by another mile per hour makes a lot more difference than increasing by 1 mile an hour on a residential street, you know, 15 to 16 miles per hour or something. And again, speed at impact predicts crash severity. That's a super consistent finding. So all else equal, a faster traveling vehicle will do more damage than a slower traveling one. Something that I'd like to note though is that we didn't measure following distance. So I had mentioned that adaptive cruise control tends to select a greater following distance compared to manual control. So it's entirely possible, although I'll say maybe unlikely, that the drivers who were traveling most recklessly also had selected a very conservative following distance. That being said, I think research is pretty consistent that drivers who are reckless in one way are reckless in others. So if anything, maybe they decrease the following distance. But again, this is all speculation on my part. We actually have video footage from inside the cabin, and MIT is working on some kind of machine vision algorithm to try to quantify following distance so we can get at this. But I wanted to leave that note in your head that it's sort of an unknown at this point for us. And I'd also like to just reinforce, you know, I've just spent some time talking about how people are speeding more and how crash risk goes up and so forth. But I want to reinforce that no matter what we just saw here, ACC is still a net safety improver. So the past research that has found safety benefits for adaptive cruise control are still valid. All the research I just showed you points to is that we could have even more safety benefits. Essentially, the extent to which you speed while using adaptive cruise control is also the extent to which you reduce your ceiling, your maximum benefit that you can get from it. So reducing the extra speeding behavior here is going to be key to unlocking the full safety potential of these systems. Something a little controversial that's been discussed and thrown around is the idea of driver speed limiters, essentially systems in the vehicle that will pull speed limits and hard cap you at that speed. You know, we can talk about that afterwards if you have questions, but something I'd maybe point people to is the graph that I showed at the end, that people who speed manually tend to speed with adaptive cruise control and vice versa. So it's possible that restrictions might just push the riskiest drivers away from adaptive cruise control, where they don't get any of the benefit anymore, ironically increasing the crash risk. That's something that we'll have to look into more in the future. That being said, you know, intelligent speed monitoring systems have shown some promise, especially in Europe, where they're maybe a little bit more liberal experimenting with these kinds of things. And so, you know, maybe that's something we'll see here in the future, particularly for stuff like long-haul truckers. So, yeah.
Great. Thanks, Sam.
Oh, sure. You're running low on.
Sorry, I go ahead. I cut you off.
That's okay. I was just going to say, you know, it's the current study was only included in, we only looked at roads in Massachusetts. And so it's possible that in more rural areas with faster speed limit roads, you might see different effects because, like I said, it happened on the slowest roads. And also we only looked at limited access road engagement, and some work has shown that 10% of engagement happens on surface streets. So, you know, who knows what's happening there, but future research could look into it. There we go. So you weren't far from the end there, Alex.
All right. Well, thanks so much, Sam. Really interesting stuff. We got a lot of questions coming in from a variety of people, so I'm going to try to get to as many of them as I can. And I guess the first one is there was a higher probability for people speeding when they were using the adaptive cruise control or the pilot assist compared to manual. How do you account for their decision to choose whether to use it? Like, are they may be more likely to choose to not use the systems when it's stop and go traffic, and then they're therefore less likely to be speeding?
That's a great question. And I actually neglected to mention part of the data winnowing process was to, so NHTSA has defined free flow traffic as traveling within 5 miles per hour of the speed limit or faster. So, on a 60-mile-per-hour road, if you're traveling 55 or over, it's quote unquote free flow. And so we did want to clarify that because, obviously people are going to try to use cruise control when there's less traffic. And if it's stop and start, you're not going to use cruise control, and that would mess the whole thing up. So we used that definition for free flow and only looked at periods where people were traveling within 5 miles an hour or over of the speed limit. And obviously that's not perfect. It would have been better to be able to quantify traffic using a forward-facing video camera or something. But I'm pretty confident in that filtering process to at least mostly isolate periods of free flow.
That makes sense. And we do have a question about just traditional cruise control without that following distance mechanism. Are they similarly likely to speed, or does the following distance make it even more likely?
That's a good question. And I'm afraid I can't answer that with any data because, we didn't measure that. That being said, if I were to speculate, I'd probably say that adaptive cruise control is a little bit more permissive in terms of the situations you can use it. So it might be a little bit more set it and forget it, which leads people to speed more while they use it. Yeah, but that being said, we didn't collect any data on traditional cruise control, so I can't really say.
Great. And one question we have is the increased crash risk that you referred to. Is that for the vehicle itself, or does that apply to surrounding vehicles as well, who, of course, might not be equipped with the advanced systems?
Right. So the increase refers to the driver of the vehicle only. So the studies that Elvik summarized were essentially injuries to the driver given certain that driver travel speeds. So it doesn't refer to any kind of collateral damage or anything like that. No.
Okay, that's helpful. And I guess in terms of the larger responsibility going forward, do you view that it rests more with the drivers to know how to responsibly use the system, or the auto manufacturers and the dealers to make sure that the system is set up so that it's optimized for safety?
Yeah, that's a tricky one. I'm reluctant to place all the blame on system design because ultimately people are going to make decisions, and it's not necessarily up to the automaker to make all those decisions for the driver. That being said, something we've noticed is that, and this isn't just us noticing it, this is sort of the field of human factors, is that the design of a system will influence how people use it. So maybe a concrete example is the 5 mile per hour toggle. It's possible that, left to their own devices, a driver might select 3 miles per hour over, but hey, there's a toggle, so I'll just bump it up 5 miles. When we presented this to the automakers involved with the vehicles, we gave the participants, a couple of them made comments about the toggle that made me think they were paying attention to that as a potential mechanism for the cause of the speeding. So yeah, just to sort of sum up my ramblings, it's, most of the responsibility, probably falls on the driver's shoulders, but the way that we design systems will affect behavior, and so we need to take that into account when we make decisions.
And when you found, or the Highway Loss Data Institute found a decrease in crash claims, or insurance claims rather for vehicles with adaptive cruise control. That would seem to imply that the following distance, I guess, mechanism or aspect of the system has really large safety benefits. Considering your research would find that the increased speed alone would lead to more crashes, perhaps. Is that fair to say?
Yeah, I mean, increased following distance is definitely part of it. You should also probably consider it might make people change lanes less. So if you're driving manually and you come upon a slowdown, maybe you'll change to get around them or something. But if you're in the mindset to use your adaptive cruise control and you have it on, you might be a little bit more patient with a small slowdown, if you're feeling lazy or motivated to just let the system control the speed. So it's hard to quantify exactly which part of adaptive cruise control is helping here, but following distance is definitely part of it, because in the end, speed and following distance kind of go hand in hand in terms of crash outcomes. Yeah.
And I thought that the discussion of the speed limiters versus the intelligent speed adaptation, I thought that's a pretty interesting one. I don't have a crystal ball, but I imagine a hard speed limiter would probably not be very popular in Washington. But I think the intelligent speed adaptation options, kind of going along with driver monitoring have some potential. Can you talk maybe just a little bit more about the different types of systems that can be included in that, driver feedback arena?
Mm-hmm. Well, yeah. So I'm not an expert on this stuff, but I did do a little bit of research on it in writing this paper. One of the ones I found the most interesting was the warning only version. So you can picture you're in a vehicle, you're driving a certain speed, and the system knows that the speed limit is 60, say, and you start approaching that. Obviously, one version would be a hard cap. You can't travel faster than 60. Another version would just be, warning, you're over the speed limit. In other words, just an audio or audio visual warning only, but it still lets you speed. Research has actually shown that reduces speeding behavior alone. So in terms of consumer outrage, it's possible that might be a nice avenue to pursue. And I know some navigation systems do this. I think Waze does it, maybe Google Maps in some states. So yeah, as far as I understand it, there's the hard caps, which work obviously because it's literally impossible to drive faster than a certain speed. But then there's a whole consumer outrage angle. And then there's the warning only, which probably are less effective in terms of actually stopping speeding, but still work more than nothing. So that's definitely promising, I think.
And I guess the last question is, you identified a few different research needs in your second to last slide, maybe looking at more rural roads, roads with even higher speed limits than 65, which we know are more dangerous, as you said, but also maybe those higher speed limits seem to have less of a differential between manual and the adaptive cruise control. What do you see, the biggest need, the biggest next step for the research community?
I would probably say something, I'm really interested in the following distance angle, both because as one of the audience members pointed out, following distance is a huge part of why adaptive cruise control is so helpful in terms of reducing crashes. I think it would be important to understand the relationship between following distance and speed, and also in terms of the use of the system. So what we found is that in the period where drivers turn off the system, the adaptive cruise control, they tend to speed up immediately afterward, which kind of signals in my head to they use manual control to pass. And so I would be curious to see how following distance affects that. So if somebody is going quite slow and you slow down and your following distance is too high, and then maybe people start cutting in front of you because people look at that large following distance as an opportunity to pass you. I'd be curious to see the behavioral interactions between all of that happening and then drivers using or not using adaptive cruise control. And I think we'll be able to answer that question maybe within the year or the next year, kind of depending on how quickly MIT can get this algorithm together.
Super. Well, and it's 10:30, so I'm sure we've got plenty more questions, but unfortunately we are out of time. Happy to share the video with anyone who wants to share it with their colleagues, and we'll certainly pass that along to you probably in the next day or two. But to close, I just want to thank Sam and the team at IIHS and MIT and all your partners for the great work that you're doing. I think it's a really interesting topic. I think it's an important subject as we see more and more vehicles being equipped with these advanced systems. So keep up the good work, and we're really grateful to have you here this morning.
Thanks, Alec. It was fun. If anyone wants to email me any questions that didn't get answered, you can see my email address on the last slide. I'd be happy to field any questions.
All right. Take care, everyone. Have a good day.